is only two functions. I'll show you the derivative of the inverse sine and the derivative of the inverse tangent. Those are the most two popular inverse trigonometric functions. But tomorrow I'll give you the rest of them. Probably I'll give you the rest of the derivatives. For the homework, to complete homework 3.5, you need the inverse sine and the inverse tangent. All right. So let's start with the inverse sine. We'll start with y equals the inverse sine of x. This is the same as saying y equals the arc sine of x. Okay? And we are interested to know in finding d dx of the inverse trig function, like so. So how are we going to go about it? First of all, let's look at the domain of the inverse. Let's record the domain. We're going to need it later on. The domain of the inverse sine of x. If you recall, in order to have an inverse function, the function has to be 1 to 1, right? It has to pass the horizontal line test. Well, the sine, being the sine, does not pass the horizontal line test. It's not 1 to 1 unless we restrict the domain. And normally we restrict the domain of the sine over negative pi over 2 to positive pi over 2, like so, including the endpoint. The reason being, if you look at the graph of the sine, okay, remember we start at 0 and we're going to go like this, something like that actually. Then we come back. This is from pi, negative pi to pi, right? Obviously we failed the horizontal line test, so it's not an invertible function. But if we'll chop it off right here, and right here means this is pi over 2, and we'll chop it off right here, and this is negative pi over 2, well, this section is 1 to 1, and therefore it's invertible. So that's why we restrict the domain from negative pi over 2 to pi over 2. In other words, this is the first quadrant, this is the first quadrant, and this is the fourth quadrant. It becomes significant later on. Okay, so there is a reason why I'm showing you now. Now let's go back to the original. If y equals the inverse sine of x, then x itself is sine of y. Okay? That's by definition. Remember, the inverse sine gives you back the argument of the trigonometric function, or the angle, if you will. So if the angle is y, then x, well, x is the input of the inverse, then x is the function value, and y is the argument, or the angle. Okay? So just make sure that we keep track of what is what. So now we implicitly differentiate x equals sine of y. Do I need to stick e here after implicitly? Or this is correct, implicitly differentiate? English major. We have no English major here. Since when English major are taking calculus? All right, to take d dx of this thing, and we get 1 is the derivative of x, the derivative of sine is the cosine, right? And then the derivative of y is y prime. Go back to Leibniz notation, dy dx. Remember, this is what we are interested in. We want y prime, but the derivative of the function y equals the inverse sine of x. So essentially, from here we get dy dx equals 1 over cosine, or d dx of the inverse sine is 1 over the cosine. But at the end of the day, I need to express something in terms of x, right? Because I want to find dy dx. So what do we do with the cosine? Well, we go into the basic trigonometric identity, and we record that cosine squared y plus sine squared y equals 1, and therefore the cosine itself, cosine squared initially, will be 1 minus sine squared y. But what is sine y? Sine y is x. Okay, so you see the dirty trick here? So the cosine squared is 1 minus x squared. And with this, we are able to eliminate the y in the derivative. So we need to take the square root, and here we have plus or minus the square root of 1 minus x squared. And now we need to stop and think. I have two values. Now this goes against the idea of inverse of a function, right? The function, one input, you have one output. The inverse is to be a function as well. So we cannot have two values. We go back to the restriction of the domain. Okay? If the cosine, if the domain of x is negative pi over 2 to pi over 2, the cosine cannot be negative. We are talking about the first and the last and the fourth quadrant. Okay? On these quadrants, the cosine cannot be negative. So we pick up only the positive. Again, cosine y is positive on negative pi over 2 comma pi over 2. Okay, so now we have cosine y equals 1 over square root of cosine y is the square root of 1 minus x squared, and let's bring it home, and we're going to say dy dx or d dx. Y is the inverse sine, so d dx of the inverse sine of x, like so, will be 1 over cosine y, except instead of cosine y, with the square root of 1 minus x squared. And this is the derivative of the inverse sine. Again, the value is, it means that every time you see the square root of 1 minus x squared, you can replace it as the derivative of the inverse sine. When you do integration, this will become a very important property.